Okay. So the first set of problems is asking us to use the fact that the trigonometric functions are periodic to find the exact value without using a calculator. So let's see the first one. So in the first question, question number 11, we are given sine 405 degrees. So 405 degrees. Now, since this is given in degrees, you can just know the fact that you start with 0 degrees, and then by the time you complete one revolution and reach back, you have covered 360 degrees. Now, 405 degrees is exactly 45 more than 360 degrees. So this is where my 405 degrees is. So what this tells me is that sine 405 degrees is going to have the exact same value as sine 45 degrees. And if you recall this in your on your unit circle, the point that corresponds to this terminal side is going to be root 2 over 2, root 2 over 2. And because this is a unit circle, the x values correspond to cosine of the angle and y values to the sine of the angle. So that means sine 45 degrees is root 2 over 2, and that is your answer. Question number 13 is asking you for tangent 405 degrees. Now we are at the exact same point, right? Now tangent, what is tangent? Tangent is nothing but y over x value. So this is nothing but root 2 over 2 over root 2 over 2, which is 1. That takes us to the next problem. And the next problem is question number 15. And question number 15 is what is cosecant 450 degrees? Now again, let's find out where 450 degree angle is. So 450 is 0 to 360, 1 revolution. And what is 450 minus 360? If you did that, you'll get 90 degrees. So this is telling you that after you finish one revolution, you have to travel 90 degrees more to reach 450 degree angle, right? Now look at the unit circle coordinates here. So this point is going to be 0, comma 1, right? So this means that cosecant, so you can do cosecant two ways. You can either think of cosecant 450 degrees as 1 over sine 450 degrees, and sine 450 degrees seems to be 1, right? The y value is 1. So 1 over 1 is 1. Okay. That takes us to the next problem, 17. 17 is what is cotangent 390 degrees. Where is 390 degrees? Let's see. We might have to take this down. Okay. 390 degrees. 390 degrees is 360 degrees plus another 30 degrees. So that is 390. So cotangent 390 is coterminal with 30 degrees. So this is going to have the same value as cotangent 30. What is another way that we can look at this? We can look at this as 390 is nothing but 360 plus 30, right? And cotangent, the period is 80, so 80 times 2, 360 plus 30. So this has the same value as cotangent 30 degrees. Now, what is cotangent? So let us write this x and y here. So the x is root 3 over 2, y is 1/2. Cotangent is nothing but x over y. So cotangent is x over y. So x over y will give you root 3 as the answer. Because root 3 over 2, let me just show that to you. Root 3 over 2 over 1/2 is root 3 over 1, which is root 3. If you don't know how to simplify this fraction, think of this as setting it up as keep the numerator fraction, change the division into multiplication, and flip the denominator. And then this and this gets cancelled away, giving you root 3 as the answer. Okay, and that takes us to question number 19. I will take 19 all the way down. So question number 19 is what is sine 9 pi over 4? Question number 21, I'm just writing these down. 21 pi. And question number 23 is secant 17 pi over 4. And then we have question number 25 is tangent 19 pi over 6. Okay, so now let's move down so that you can see this. Okay, so these are our questions. So the first one, so all of these angles are given in radian measure. Okay, so I'm going to teach a technique for you. If you want, you can use this. So I'm going to write this as, if I'm going in radians, one revolution is 2 pi radians, 2 revolutions is 4 pi, and so on. So every revolution is 2 pi radians. Now this angle is given with a denominator of 4, right? So let me convert everything to a denominator of 4. What is 2? 2 is nothing but 8 over 4. So this can be written as 8 over 4. It's the same as 2. 4 can be written as 16 over 4 is also 4, and so on. Now that makes you see very clearly that 9 pi over 4 is here, right? 9 pi over 4 is very close to 8 pi over 4. This tells me that I finish one revolution and then I travel pi over 4. You get that? Because 9 pi over 4 minus 8 pi over 4 is pi over 4. So if I were to draw this angle, how will this angle look like? This angle will be, I complete one full revolution, that is 8 pi over 4, and then I travel another pi over 4. So this is what I have. So this tells me that sine 9 pi over 4 is going to have the same value as sine pi over 4. What is sine pi over 4? It is root 2 over. The next one is tangent 21 pi. Now, this is an odd multiple of pi. So all the even multiples of pi are going to land here, right? 0, 2 pi, 4 pi, and so on. Where do all the odd multiples land? They land here, correct? It is pi, 3 pi, 5 pi, 7 pi, and so on. So this is the angle that we are looking at. So tan 21 pi will have the same value as tan pi. What is tan pi? At this tan pi, what I'm going to have is my point is negative 1 comma 0. And tangent is y over x. So 0 over negative 1 is still 0. So tan pi is 0. Then we have 17 pi over 4. Now let's go and write down what we did for question 19. We wrote that all of the revolutions are going to be in this order, right? Like so. And we converted it into denominator of 4. So we had 8 over 4, 16 over 4, 24 over 4, and so on. So now that tells me that 17 pi over 4 is going to fall here. So what this tells me is that 17 minus 16 is pi over 4. So secant 17 pi over 4 will have the same value as secant pi over 4. Now what is secant pi over 4? If you recall your unit circle, pi over 4 is here, and this is root 2 over 2, root 2 over 2. So this is a unit circle. So remember the radius is 1. So secant is nothing but the reciprocal of cosine. So this is 1 over cosine pi over 4, which is 1 over root 2 over 2, which is 1 times 2 over root 2, and that is root 2. So secant pi over 4 is square root of 2. Question number 25. Tangent 19 pi over 6. Again, let's write this 0, 2 pi, 4 pi, etc. Now I want to write it with the denominator of 6. So I have 0, 12 pi over 6, 24 pi over 6, and so on. So that puts my 19 pi over 6 right here. Okay. So if I subtract 19 minus 12, I get 7 pi over 6. So what is this telling me? It's telling me that tangent, well, for tangent, I can even have pi as the period. So if I want to do it that way, I could change this also. So let me show you that. So you have this idea, but for tangent and cotangent, so for sine, cosine, cosecant, and secant, keep 2 pi as the period. Whereas for a tangent, the period is pi. Okay, so that means we could have gone one more. So we could have taken away one more pi, right? So that means tangent 7 pi over 6 is going to be also having the same value as tangent pi over 6. Okay, but if you did not know that, that is okay. You can still work with 7 pi over 6. Now, where is 7 pi over 6? 7 pi over 6 is here. Okay, so in this quadrant, tangent is positive, right? So the tangent is positive, and the coordinates here are going to be negative root 3 over 2, comma, negative 1/2. And tangent is nothing but y over x. So that will give you negative 1/2 over negative root 3 over 2, which is 1 over root 3 or root 3 over 3. And you would have got the same answer if you have used pi over 6 as your angle instead of 7 pi over 6 that we used for this one. It's the same thing. Okay, now let's see the next set of questions. In the next set of questions, you are asked, in which quadrant does the angle lie? Okay. So to do that, let us just draw a simple diagram here. So in quadrant 1, right? In quadrant 1, remember, x and y are both positive. In quadrant 2, x is negative, y is positive. In quadrant 3, both x and y are negative. In quadrant 4, x is positive, y is negative. So according to this question for 27, what they're saying is that when they say that sine is greater than 0, what they mean is y value is greater than 0. Greater than 0 is also saying positive. So for question number 27, what they are saying is that y is positive. That's what they are saying. Cosine is less than 0 is another way of saying x is less than 0 or negative. Okay. Now, in which quadrant is y positive and x negative? So the quadrant in which y is positive and x is negative is quadrant 2. And that is the answer for 27. 29. What is the question telling you? It is telling you that y is negative, and it is saying that tangent is negative. So tangent is negative, okay? So where is tangent negative? So let us do another quick chart for tangent. So tangent and cotangent, they are going to follow the same thing, okay? Now, when both x and y are positive, tangent and cotangent are positive because x over y and y over x are still going to be positive. Now, however, in quadrant 2, when you have one positive and one negative and you divide them, you will end up with a negative number. In quadrant 3, what happens is, since both of the numbers x and y are negative, when you divide them, whichever way, it's going to end up with a positive value. And finally, this is also going to be negative because positive over negative or negative over positive is still negative. So you have to understand that sine and cosecant are similar. Cosine, secant are similar. They're both going to follow the x value. So cosecant and sine will follow the y value. Secant and cosine follows the x value, whereas tangent is a quotient of them. So this is what you have for tangent. So now let's see. Tangent is, according to question 29, tangent is negative. So where is tangent negative? Tangent is negative either in quadrant 3 or quadrant 4 or quadrant 2. So these are your two choices, right? But out of these two choices, the only choice for which y value is negative is 4, right? So if you compare the two tables top and bottom, the only possible answer is quadrant 2. Okay, next one. Question number 31. I'll take it down. So question number 31 is cosine is greater than 0. Tangent is less than 0. 33. Secant is less than 0. Sine is greater than 0. Cosine is greater than 0. So where is cosine positive? Cosine is positive either in quadrant 1 or quadrant 4. So these are the two possibilities. Where is tangent less than 0? Tangent is negative either in quadrant 2 or quadrant 4. Now, what is common to both? What is common to both is quadrant 4. So my answer is quadrant 4. Secant or cosine is less than 0 in quadrants 2 and 3. Sine is greater than 0 in quadrant 1 and quadrant 2. So what is common between them is quadrant 2. And that's the answer. Let's see the next set of questions. All right. So let me copy down these questions. The first one, so here, what is given to you is sine theta is given to be negative 3/5. Cosine theta is 4/5. The question is asking you, find the value of the remaining trig functions. This time. So here you have to remember that sine theta is nothing but y over r. Cosine theta is nothing but x over r. Tan theta is y over x. Cosecant theta is r over y. Secant theta is r over x. Cotangent theta is x over y. Okay. Since sine is positive and sine is negative and cosine is positive, that immediately tells me that my theta is in quadrant 4. Okay. So cosine positive, sine negative. But you don't even have to know that for this problem. because both sine and cosine are given to you, the rest are going to follow pretty smoothly. So let's see how they're going to follow. So what I'm going to do here is, because sine is given, I'm going to write it like so. This is negative 3 over 5. Cosine is given to be 4 over 5. So if I were to draw this angle, right, where this angle may be, this angle is in the fourth quadrant. And so 3 and 4, somewhere here. Okay, so this is where my angle is. So this is where my angle is, right? Now, one thing that I know is that the radius, so if I were to draw a triangle, right? So if I were to draw a triangle like this, what I know is the radius is the hypotenuse and that radius is going to be 5. Okay. And if you want, you can write this as negative 3, and then you can write this as 4. Okay? This is my triangle. Then what I'm going to say is that I know this relationship. The relationship is x squared plus y squared is r squared. So my x value is 4, y value is, if you're thinking of a triangle, just 3, and then you put the signs back. But here I'm just going to keep the sign like this so that it's less confusing for you. Then I have to find the r. Well, I do know what the r is, but I'm just showing you. In this case, it's given to you, the r was given to you, and the y was given to you. So anyway, you do this and you'll get r is equal to 5. So it doesn't matter. It's unnecessary. We know the values. So we know what x is, what y is, what r is. So if you want, if this helps you for all of these problems, you can do this. You remember that this particular angle theta, and we are interested in all the 6 trig ratios for this angle theta. And for this angle theta, the x value for this particular problem is 4, the y value is negative 3, and the r value is 5. So this is the set that we have. Now we can just plug in the values. Now, y over x is negative 3/4. R over y is negative 5/3. R over x, 5/4. X over y, negative 4/3. So once you have the x, y, and the r, you can just put the values in their places. R is always positive. Okay. Okay, so the next thing here is both sine and cosine are positive here. That puts me in quadrant 1. So sine theta is nothing but y over r, right? And that is given to be 2 root 5 over 5. Cosine theta is x over r, and that is given to be root 5 over 5. So I know my x, I know my y. I'm just going to write these values down. So y over x will be 2 root 5 over root 5, which is 2. Cosecant theta will be the reciprocal of this, r over y, or just flip this. You have 5 over 2 root 5, which is root 5 over 2. Secant theta is 5 over root 5, which is root 5, because 5 is nothing but root 5 times root 5. Then cotangent theta is the reciprocal of 2, which is 1. Okay, takes us to question number 13. Let me write that down. Okay. Sin theta is 1/2, cosine theta is root 3. Sin theta is equal. These are unit circle values for 39. I can do what I did before, but anyway, I'll do the same thing. So I have quadrant 1 angle because both x and y are positive. So I'm going to write sine theta as y over r, which is 1/2, cosine theta x over r root 3 over 2, tan theta y over x is 1 over root 3 or root 3 over 3. Cosecant theta is 2 over 1. Secant theta is 2 over root 3 or 2 root 3 over 3. Cotangent theta is 3 over root 3, which is 3. Okay, next one. Sine is negative, cosine is positive. That puts me in quadrant 4. So sine theta is y over r, which is negative 1/3. Cosine theta is x over r, which is 2 root 2 over 3. Tan theta is y over x, which is negative 1 over 2 root 2. You can rationalize this by multiplying and dividing by root 2, and that gives you negative root 2 over 4. Okay. Then cosecant theta, flip it, you get negative 3. Secant theta, flip it, you get 3 over 2 root 2. Multiply and divide by root 2, you get 3 root 2 over 4. Cotangent theta will be, flip your thing, you'll have negative 2 root 2. Okay, so these are your values for 41. Now let's see the next set of problems. Okay, here find the value of the remaining trig function of theta. Okay. 43. Sine theta is given to be 12 over 13 and theta is in quadrant 2. Wait, it's asking you for everything else remaining? Okay, each of the remaining functions. All right, so let's see how many of these we are going to do. Sine theta is 12 over 3, okay, in quadrant 2. So my angle is 12, so y over r, correct? So what this is telling you is, oh, I'm sorry, this is in quadrant 2. So quadrant 2, my angle is like this, right? So the y value is given to be 12 and this value is 13. So what is missing here is the x value, okay? Because what is given to you is y over r. Y over r is given to you, but x is not, right? Okay, but remember this is in quadrant 2. So let's first find out x squared plus y squared is r squared. Okay? Then x squared plus 144 is 169. X squared is 25. X can be either plus or minus 5. Now, because this is quadrant 2, I know that x has to be negative. So the only possible value for x here is negative 5. So now I have all my values, right? I have x as negative 5, I have y as 12, and I have r as 13. So now I can write all the remaining values. Cosine is x over r. Tangent is y over x. Cosecant was 13 over 12. Secant is 13 over negative 5. Cotangent is negative 5 over 12. . Sorry. So now cosine is given to you in quadrant 3. So quadrant 3 angle, and this is what you have. The hypotenuse or the radius is 5, and the x value here is -4, right? But we don't know what the y value is. So set up your equation. X squared plus y squared is r squared. So you have -4 squared plus y squared is 5 squared. So if you solve for this, y will be plus or minus 3. Now, because it is in quadrant 3, y is also negative. Therefore, y is -3. So now since I have my x as -4, y as -3, and r as 5, I can write all the values. So sine theta will be -3/5. Cosine theta is -4/5. Tan theta is 3/4. Cosecant theta is -5/3. Secant theta, -5/4. Cotangent theta, 4/3. So that will be your answer. So let's just pick a few problems because this category is the same. We can not have to everything. Okay, so all right, let's pick one problem per time. Okay, so here in 47 to 50, we are given angles. So let us do 47. Okay, let's do 47 and 49. All right, so 47. Just remember, this is quadrant 2, so x is negative. So that means x is -12, y is 5, and r is 13. So then write all your other values. So sine theta is 5/13, cosine theta is -12/13, tan theta is 5/-12, cosecant theta is 13/5, secant theta is -13/12, cotangent theta is -12/. Now same thing here. Pi/2 to pi is also quadrant 2. So then you have something like this. Your x value is 1, r value is 3. You have to find the y value. So x squared plus y squared is r squared. So 1 squared plus y squared is 3 squared. So y squared is 9 minus 1 or 8, which means y is plus or minus √8 or plus or minus 2√2. But because it is in the second quadrant, I know that y is going to be positive. So I'm only going to use positive 2√2. So now let's summarize all our values. Sine theta will be 2 root 2 over 3. Cosine theta was negative 1/3. Tan theta will be negative 2 root 2. Cosecant theta is 3 over 2 root 2, which is 3 root 2 over 4. Secant theta is negative 3. Cotangent theta is negative 1 over 2 root 2, which is negative root 2 over 4. So here, sine theta is positive and tan theta is negative. So sine theta is positive only in quadrants 1 and 2. Tan theta is negative in quadrants 2 and 4. So what is common is quadrant 2. So my angle is in quadrant 2. So angle is in quadrant 2. What I have is a triangle like this. The y value is 2. The radius is 3. What is the x value? So x squared plus y squared is r squared. So x can be either plus or minus root 5. But because it is in quadrant 2, I know that x is negative. So x is negative root 5. So once I get that, I can write all my trig ratios. Sine theta is 2/3. Cosine theta is negative root 5 over 3. Tan theta is negative 2 over root 5, which is negative 2 root 5 over 5. Then cosecant is the reciprocal of sine. This is the reciprocal of cosine. And cotangent will be reciprocal of this. So these will be your. Let's see the next set of problems. Okay, so those are repeating. All right, so here we are asked to use the even odd properties and we have to find the values without a calculator. Okay, so remember that sine function is an odd function. So sine negative 60 has the value of negative sine 60. And sine 60 is root 3 over 2. So this is negative root 3 over 2. 61. Tangent negative 30. Tangent is also odd. So this is negative tan 30 and which is negative root 3 over 3. Secant negative 60. Secant is even function. So this is the same as secant 60. So cosine 60 is 1/2. So secant 60 is 2. Sine negative 90. Sine is an odd function. So this is negative of sine 90 degrees. And sine 90 degrees is 1. So this is negative 1. Tangent is an odd function. So this is tangent, negative tangent pi over 4. And tangent pi over 4 is 1. So this is negative 1. Cosine negative pi over 4. Cosine is an even function. So this is cosine pi over 4, which is root 2 over 2. Tangent negative pi is the same as negative tangent pi. And what is tangent pi? Tangent pi is 0. So this is 73. Cosecant negative pi over 4. Cosecant is an odd function. Negative cosecant pi over 4. So cosecant pi over 4 is root 2. So this is negative root 2. Secant negative pi over 6 is the same as secant pi over 6. And secant pi over 6 is, so this is root 2 over root 3 or 2 root 3 over. Okay, so we're finding the exact values without using a calculator for the next set of problems. Let's see.